All right, let's look at problem 3.2 again, completing the square. A lot of people have trouble with this because you haven't done it for a long time, and it's always kind of tricky. I did an example like A in class already. We can go over, like, let me just go over B, one of the easier ones, then I'll do like C and D, or go over C and D because there's definitely a little bit trickier. Remember what you do is you do the X's and Y's separately. Like here, let's look at the x's. Since it's x squared plus 4x, you always go x plus, since it's a plus sign, it's plus, and you take half of the number in front of that, which is 2, and you square it. Now, if you were to square this out, you get this one squared, x squared, plus this one squared, which is 4, plus 2 times them multiplied together, right? The cross terms, you always get 2 of them. You multiply them together, which is 2x times 2, which is 4x. Notice we have an x squared, we have a 4x, right? Here's the x squared and the 4x, but we don't have the 4. So if we write this, we have to take away the 4 so that this thing here is exactly the same as x squared plus 4x. So we're going to replace the x squared plus 4x with an x plus 2 minus 4, x plus 2 squared minus 4. And then this can be what a circle formula is. We want x plus something squared or x minus something squared. Then at the end, we put all the numbers, like the minus 4 and the 9, we put all the numbers on the other side. If it's not positive, then you did something wrong, because it has to be positive, because that's the radius squared on the other side. Okay, let's do a tricky example like C here. They throw some fractions at us. So you immediately, oh, no, not fractions. But that's okay. We're tough. We can do it. So let's do the x squared one. X squared plus 1/3 x. So just like before, you write x, it's plus, since it's a plus sign. You take half of the number in front of the 1/3. 1/2 of 1/3, right? 1/2 times 1/3 is 1/6. So plus 1/6 squared. Now, if we square this out, just to check, it's going to be x squared plus this squared, which is 136. 1/6 times 1/6 is 136, plus 2 times them multiplied together. Multiplied together is x over 6, so that's 2x over 6. 2x over 6 is the same thing as x over 3, or 1/3 x, which is what we had, right? Which is 1/3 x. We had a 1/3 x. So we're good, except we have, again, this thing squared too much. We have a 136 we didn't start off with, so we have to go minus 136. Then we do the same thing for the y squared. We go y minus now, because it's minus half of that number. So we go plus y minus half of this number. So multiply by half means just multiply the bottom by 2, right? So that would just be 10/6 minus 10/6, and we square it. We can, of course, simplify that as 5/3. I'm just going to rewrite it as 5/3, right? So 10/6 is the same as 5/3. So I'm just going to save myself some trouble here and rewrite it as 5/3. Now, as will always happen, we're going to have 5/3 squared, this number squared, too much. It'll always be too much, because this will always be positive. Even if it's negative, a negative times a negative is a positive. So we're going to have to subtract out 5/3 squared, which is 25 over 9, right? 5 squared is 25, 3 squared is 9. Because we're going to have that too much. And then we can leave the 127 over 9 on the other side, because that's where we're going to put all the solid numbers anyway. So we can leave that there. So that's equal to 127 divided by 9. Now we want to put all the fractions on the other side. All the numbers like this and this one on the other side. Notice these will always be minus, so they're always going to be positive on the other side. We have a 9 in the bottom. Here we have a 36 in the bottom. So we should probably change all the denominators to 36. So I'm going to rewrite this as x plus 1/6 squared plus y minus 5/3 squared equals, okay, 1/36 plus this one, which I can multiply by 4 to get 36, multiply the bottom by 4, multiply the top by 4, 25 times 4 is 100, so that's plus 136, plus, we already had this one here, multiply the bottom by 4 to get 36, 4 times 127, oh, what's that? 4 times 125 is 500, and so we have 2 more, so 508 I think, we have 2 more than 500. Hopefully I did that right, so 508 over 36. Alright, so let's add up all those. 101 plus 508 is 609. 609 divided by 36. So, they say find the center and radius of each of the following circles. So I did this right? 1 plus that's 509, 609. Okay, assuming I did all this right, which you can check my algebra. But the idea is right. We know the center is at -1/6 because it's a plus there. It should always be a minus, so it's -1/6. So -1/6, comma 5/3, whatever this number is if it's a minus. So 5/3, that's the center. And the radius is always the square root of the number on the right side. So it's a square root of 609 divided by 36. Now maybe that's going to be a pretty number. I haven't plugged it into my calculator yet. Let me try that. What's 609 divided by 36 square root? I just can't believe it will be, but 609 divided by 36, that's square root. Okay, that's, I would just leave it as 609 divided by 36. Now, square root of 36 you could do. 609 is not going to have a pretty square root. Let's try that. So, 609. Yeah, it's like 24.67. So you could rewrite this as square root of 609 divided by 6, because square root of 36 is 6. Doesn't matter. It's just the square root of this number, because this is the radius squared. Okay. D, you do the same way. For D, put all these on the other side. That's the first step. They try to mess you up by putting things on the wrong side. So you write these over here, so it'd be x squared minus 3/2 x, right? Because positive of 3/2 x this side is minus, plus y squared plus y. And we can leave that number over there, because that's where it's going to end up anyway. All the things without y's and x's we put over here. Now you do the same thing. The number in front of here is a 1, so it's going to be a 1/2. Right? It's 1/2 whatever the number in front of the y is. So you're going to be y plus 1/2 squared. X minus 1/2 of that, so 3/4 squared. And you do the same thing. It's good practice with fractions, finding common denominators to add all those things together. Okay, but that's the idea of completing the square. And that way you can make it look like a circle. You write it in an equation that you can immediately read off the center of the circle and the radius of the circle, which is really useful to do. So, okay. Yep, thanks. I'm trying to get away from saying, hope that helps, and thanks for listening, which I do every single time, but I don't know what else to say. So, yeah, okay.